Hello everybody. So the next method of tunneling is boring method. Okay, so with this method we will use a tunnel boring machine as a mechanical device so that it can excavate at one time using a variety of cutting tools that depend on ground condition. So usually the TBM is designed to support the adjacent soil until temporary and subsequently permanent until linings are installed. So what I can say about tunnel boring machine is that this is like a factory. Okay, so this is the cutting machine, and then all the soil, all the cutting soil will be delivered to the backside, and then at this factory they have like a concrete panel factory, so that all the excavated soil will be backed up by the lining installed using the precast panel. Okay, so usually this is a very important machine to making tunnel in present time. Like in Malaysia, we have smart tunnel, we have the MRT tunnel, and usually a tunnel boring machine is very effective when we are dealing with the urban area. So tunnel TBM, also known as a Mohd, which is a machine used to excavate tunnels with a circular cross-section through a variety of soil and rock strata. So the method of construction. So do you remember that I said that a tunnel is an enclosed area, but it needs open space. All right. So for TBM method, we have the launching shaft. Okay, so that we will launch the TBM here, and this is the retrieval shaft, which is this is the starting point, and this is the last point, so that we will assemble here and disassemble at this point. So first we need to excavate of the launching and retrieval shaft. And then a second step, we need to assemble the TBM in the launching shaft. So we assemble here, alright. And the third step, the tunnel construction is begin, okay, below the urban area. And finally, after it reach the end of the tunnel line, so we will disassemble the TBM in the retrieval shaft. So just a simple like that. So benefit of using TBM, okay. So many benefits. You can study it here. So what we can say is about the disadvantages. Okay, some of the disadvantages is the high cost due to the needs of supporting things such as conveyor belts and anything. All right, but if we compare apple to apple, all right, the TBM method and also another method, we will see the high cost. But if we see the overall part, we can say that the TBM is much more cheaper and much more economical compared to the other method, because from the overall cost of the projects, it saves time. Okay, it saves many things, it saves the environment, but we cannot compare apple to apple, especially at the early stage of the construction. Oh, okay, so this is since we are excavating under the ground, so there is some safety measures that we need to beware. Okay, some of them are building settlement monitoring points, okay, building tethering monitoring points, ground settlement monitoring points, automatic deformation monitoring points. All right, so this is the allow for 24-hour real time monitoring to be carried out as the TBM bores through. So this is inside the TBM. Okay, as I said before, this is like a factory. Okay, it has the rotating cutter head, the screw conveyor moves earth and rotating arms, right, and hydraulics rams. So this is the concrete panels that cover the excavated soil. All right, it is from the precast concrete segment delivered to rotating arm. Okay, delivered from here, and then it will cover the soil. So this is the increasing size of bog tunnel from year to year as technologies expand. So it start commercial around 1978, just around 20 feet only, and then it's increased until about 53 diameter in feet in around 2008, like that in China. So I bring you some example of bog tunnel from Moscow, Netherlands, Madrid, and also Shanghai. So these are the description about the road of the tunnel in Moscow. Okay, it's completed in 2003. The diameter and the length here, and this is at Holland. Okay, also completed in 2003. The diameter and the length is much more lengther. And this is in Madrid. Okay, completed in 2007. The length is 12,200 feet. Okay, before this is 22,000. And the last one is Shanghai Metro Line. So it is the biggest one. The diameter is no, not the biggest one. This is 2005. So the diameter is just 21 feet, and the length is not too long. Okay, Shanghai Metro. So in Shanghai Metro, they built double tunnel. So they did the double tunnel lining. So this is the segmental tunnel lining system, which is we use the precast concrete, and this is the reinforcement of the precast concrete, and this is the segmental liner fabrication. Okay, before we install, and this is the linear erection process to install the precast segment. And this is the assemble lining after we assemble all the precast concrete to the excavated soil. And the third method is immersed tunnel. Okay, compared to the two methods before, the immersed tunnel will be sunk in the water. So what is immersed tunnel? Okay, it is hollow concrete blocks, okay, immersed underwater and joined to form tunnel. So this is the space that we need. All right. So we will use precast tunnel element also constructed in the dry and floated to the destination, and lastly we lowered into place, join and cover up the tunnel under the ground in the water. Okay, so I bring you one more time the option to cross the waterways. So usually immersed tunnel is very beneficial for a short distance, all right, because it is very costly. Like in Malaysia, the immersed tunnel that is planned is in Penang, right? Not yet developed and not yet constructed, but it is just planned. Okay, immersed tube history, it first constructed about 120 years ago, and about 200 have been constructed all over the world. All right, and it is first proposed in 1860 Okay, this steel tunnels in USA. Okay, they prepare it at the dry docks. Okay, and then float to the sea before it's sunk into the water. Okay, in Europe they use concrete tunnels, but in US they use steel tunnels. Okay, types of immersed tunnel. We have concrete tunnels used in Europe, and then we have steel tunnels used in US, and we have sandwich tunnel, which is combining the concrete and the steel in Japan. And the recent development in Japan, in Osaka South Port, and also in Naha Tunnel in Okinawa. This is a very famous tunnel. It's like Aquaria KLCC. Okay, the Kobe Port Tunnel, the only steel tunnel with 3 lanes per duct. Okay, and this two is a sandwich one. Okay, so they use no reinforcement for the concretes because it is filled with a non-shrink self-compacted concretes, and it also reinforced by the structural steel plates. So this is the concrete immersed tunnel in Hong Kong. Okay, double shell tunnels. Okay, the steel tunnels used in USA in Maryland. The single shell tunnels, Cross Harbor Tunnel in Hong Kong. Okay, this is the cost effective for white tunnels. Okay, so there is no certain regulation and design for tunnel design. Okay, so each country can design their own tunnel shape. All right, so depends on the creativity, depends on the machinery, and depends on the economical phase. Okay, this is the advantages over the bridge and the myth about tunnels. So, and why immersed tunnel that usually beneficial than the bridge. And okay, for immersed tunnel construction, so this is the 6 step, the basic 6 step of construction of immersed tunnel. Okay, first we need to cast the blocks in dry docks. Okay, so usually we have a yard, so we develop and we build the blocks or our tunnel at the dry docks. And second, after it's complete, okay, we transport the blocks into the site. So usually we need barge, okay, to transport the blocks. And then we need to do the preparation of immersion. Okay, we need to prepare where is the proper position, where is the proper way to immerse the blocks. Okay, this is the setting out. Okay, we need to do the survey, right? Like we want to design a roadway. Okay, so, okay, we need to do the survey so that the location is precise. Okay, and then we need to prepare bed and dredging. Okay, so we need to dredge a trench. Okay, we prepare a gravel bed and the foundation, and then we immerse the blocks, okay, into the water after we prepare the foundation. Okay, and then we join the blocks. Okay, we are not bring the long blocks. Okay, so we bring it part by part. Okay, and then we need a watertight seal to join in the blocks. And lastly, we need to do the evacuation. We need to bring out all the water, all the pressure, and after that, lastly, we need to do the finishing and the foundation. Okay, filling the trench.